Hi everybody, back looking at some Scala native code again. This is continuing on with implementing a buffered input stream, specifically the java.io buffered input stream for Scala native. I did open up a pull request to the project where I'm tracking what I need to complete to make this suitable for merge. All the automated tests are passing, and the thing that remaining is review and some performance tweaks to bring it to the same level as the prior implementation. And then we'll and then test async close. But I'm pretty sure I can't do this yet. I don't think Scala native has the multi-threading set up quite yet, so I'll probably defer that task until such a thing is available. Although we might be able to test it using the non-native Scala compiler and just test it with the JVM-based compiler to get the multi-threading support. But not exactly sure how to do that, and it's not a priority right now, so we'll leave that till later. So what do we got? Well, let's check out do a few performance tweaks aspect. And in the code, I did add some to-dos related to that. We have two of them. One is related to skip, which, given the number of bytes to skip in the input stream, does exactly that. It moves forward position in the stream that many bytes. Potentially less if the end of stream is reached or if an I/O error occurs. But the goal is to move forward that many bytes. And as it's implemented right now, it's really straightforward, which is nice because it's easy to demonstrate it works and understand why it works, but it's inefficient. And it just sits here and repeatedly calls read until the number of actual bytes read is greater or equal to the requested, or the end of stream is reached. That is fairly easy to see that this is going to work fine. The issue, of course, is that we can skip blocks of bytes at a time. We don't need to do one byte at a time. The buffer up until count can be skipped all at once. So a more efficient implementation here is to take this number and decrement it by the distance to count, the number of bytes to count. If it's greater than that, then refill the buffer and continue to do that until the number of bytes to count is greater than the remaining bytes to skip. In which case we just iterate move position by the number of bytes remaining to skip and call it done. This will reduce the number of calls to read, which isn't terribly inefficient if there are bytes available to read. You'll see that it does do this position less than count as the first conditional, and it's able to increment that position fairly quickly. However, as part of read, there is this synchronized block that will be acquired every single iteration. And of course, we're going to be incrementing by 1 when we know we can increment by greater amounts. That is a micro-optimization that would be beneficial, although I have no performance information, no performance tests, so I can't really say how beneficial that would be. Logically, though, it would be beneficial. And, in fact, I wonder if the Scala native documentation mentions anything about performance tests. This is a Scala native webpage. They have a pretty nice getting started guide for contributors. And then this is something I mentioned last time, where there's a note about Java lib and the licenses that means it impacts how we write these things. And this is largely why I'm re-implementing this in Scala instead of just copying one of these. Is the licenses are difficult to integrate. Not impossible, but just annoying. Let's see what we have. We do have benchmarks, tests and benchmarks, no dependencies on each other. So there is a benchmark chunk. Let's go check that out. Oh, I need to, just a moment, I need to refresh my Emacs config. Problem with Emacs is that it loads code dynamically. If you update that code in the background, well, things get kind of weird. Benchmarks. Well, I actually don't see any benchmarks, so now I'm not so sure. Interesting. So that's kind of interesting. I'm not really sure what's to go there, so I'm going to go into getter.im, where a bunch of Scala native people hang out, and see what the deal is. Actually, before I do that, a possibility just came to mind that this is a git submodule. Nope. Okay, we'll leave it at that. So we'll pass on the benchmarks for now, and we will go back to buffered input stream and go ahead and start up LSP again. For my Scala setup, LSP interfaces with metals, which provides a nice integration with the compiler for Scala projects. Okay, so we're back in. Alright, well, I would be curious to replace this with a more efficient method, but I'd like to be able to do some benchmarks, so we'll hold off on that until I get some benchmarks, or some type of knowledge about how to set up benchmarks in Scala Native. I mean, there's stuff that I can do, like make a little executable that uses BufferedInputStream, and then just time the performance of that executable. But if there is a benchmarking setup already, I'd prefer just to use that. So for this one, we have this to-do here that says it's easy to exceed the stack, replace with iteration. And we can see how unsafe read would blow the stack pretty easy. Is that every time it fills the buffer and it still needs to read and it has another buffer, it pretty much just recurses back to unsafe read again. And if we look at fill buffer, there are two options here. So there's fill marked buffer and fill unmarked buffer. Fill marked buffer is going to use a buffer of double the size, while fill unmarked buffer is going to reuse the current buffer. So if we imagine the current buffer is, say, 32 bytes, just a really small buffer, and we request using the array read a length of, something large, let's say a gigabyte, right? That means every 32 bytes it's going to be recursing. So it's going to go here, it's going to say, we have some available bytes. So it's going to copy those into the destination bytes, and then it's going to refill that buffer. Then it's going to continue reading into the buffer by doing a recursion. So 32 bytes at a time for like a gigabyte, you're going to have a stack depth that's fairly large, and really it's unnecessarily large. So let's make this an iteration. One thing I want to try is, can we just do this with a tail recursive transformation? Note that this is ripe for tail recursion optimization. We have a base case that is non-recursive, then a case that is recursive, and one of the last things it does is this call to unsafe read. And it's not actually the last thing it does, unfortunately. But instead of analyzing it ourselves, we're just going to ask the compiler to do it. And in Scala, you say tailrec annotation. And what this is going to instruct the compiler to do is transform this into a tail recursive call, which then does the iteration instead of recursion. It looks like it failed, although I can't get the Emacs LSP integration to tell me exactly where it's failed. We do LSP UI. Is it, I think it's flight checklist. Quite a lot of warnings, but here we have the one of interest. Could not optimize tailrec annotated method unsafe read. It contains a recursive call not in. That's quite unfortunate. We can't see the rest of that, but we'll go back to just SBT to see the full thing. It contains a recursive call not in tail position. Yep, and that is entirely true. And it's easy to see why if we break this out. This is actually, available plus unsafe read, something like that. And you see that the last call is not unsafe read, it's actually this addition. So let's not do that. Let's make sure the last call is unsafe read. I'm going to do this the standard helper method mechanism, where I push that accumulation of the total bytes read into the helper method. Just like so. And then, of course, for the driver method, that calls unsafe read. starting with the total number of bytes read as 0. This okay. So now we have the initial bytes read as 0. And we have this recursive call, the base case here, where the number of bytes remaining to be read, which is length, or len, is available in the buffer. And we just copy those bytes, and here we return length, or the number of bytes requested. In this case, though, because we're now tail recursive, we push this accumulation down. So we want bytes read plus length, because we might have already read some bytes. So we want to return that as the last thing. And down here, we do not have enough bytes available, so we need to copy some amount from the buffer, which is available, and then fill the buffer. So if when we fill the buffer we reach end of stream, we need this to return -1. So we can't do anything about that, but if we have already read some bytes, namely available number of bytes, the available bytes, then we need to return that plus available. And likewise with next buffer here. We've read available number of bytes, and we need to continue reading some bytes. But instead of our last call being that addition to available, our last call is now unsafe read, where we pass in bytes read plus available. You know, these are common sub-expressions here, which is interesting. But we'll see if when we save that, it satisfies the compiler. And hey, what do you know? Compiler seems happy with this tail recursive optimization now. And now we'll have SBT compile it. And it does indeed compile it. And we'll go ahead and run the test. And it passes all tests. So that is pretty handy. Compared to the Harmony code, which is another JDK implementation. Let's see if we can pull that up real quick. Let's see what that looks like. Oh yeah, here we go. So this is the loop that Harmony does, which does largely the same thing. In either marked or unmarked mode, it continues filling the buffer and reading from the buffer. In this case, you'll note that there is a while loop, while true, which relies on these returns to break out of the loop when enough data has been read. And instead, we've just had the compiler do that transformation for us. We said we want a tail recursive, and the compiler guarantees it's going to make a tail recursive and do that loop for us. Then we transformed it into tail recursive form. That's it. Much easier. I mean, really, we took the non-tail recursive one, which is pretty easy to write, and made it tail recursive and efficient very easily. It's pretty cool. So I'm just curious for a second here. 422 lines. You know, I write a lot of comments, but we're at 248 lines. So pretty good. I'm pretty happy with this. Now just remains this skip, and honestly, I'm really not sure how much of a performance gain we'd get by making this not just read one byte at a time. I mean, sure, it's measurable, but it could be quite as significant. So I'm much happier with this transformation, which avoids blowing the stack, which is quite nice. Let's see if the Scala native people replied about benchmarks. Nope, not yet. Okay. Now what I'd really like to do is have a version that demonstrates, have a test that demonstrates the difference in behavior with respect to stack. I don't think that's going to be easy to do without being able to limit the stack size in Scala native. Otherwise, I'm just going to be using what, like 64-bit address space on my computer. It's going to take a while. But let's see what we got here. That went much shorter than I was expecting. That's actually all I planned to do today. Well, let's add that to the pull request. That's not a very important change. This one is. We typically use the term blowing the stack, but I don't think that's very nice. Yeah, we'll just go for that. Okay, so then we've got that in our merge request. And we'll see what the robot thinks and what people think about that. I want to see what else we got. really equivalent. Okay. Mm. Hmm. It's quite a can of worms. Arrays.sco. Let's check that out. Runtimes. Arrays.sco. Okay. see. I don't want to look at the generator quite yet. We'll just stick with the generated. Okay. See, generates one for every single primitive. What's he talking about here? Please refer to the latest version of implement array copy. Looks like an old branch. Change in the compiler. Oh yeah, this is quite the can of worms. Man. Okay. Yeah. Need to store additional runtime info for the element types of array. It's quite involved, indeed. I think I will do that quite yet. It's quite a deep one. I don't want to start on that right now. Complicated. see what else we have. Okay. Note, well, the missing space blank after the comma. Oh, yeah, I see. Missing space blank. Yeah. Agreed. Okay. Okay, so there's already a pull request for this one. Yeah, no surprise. Test framework reports alternate truths. Interesting. I just want to run these tests. I don't think we'll see the same thing. Nope. Wait a moment. Well, while that is contemplating, incomplete implementation of files, a new directory stream. interesting. Can ignore that one too. Okay. There's already a work in progress for this, so I think we'll leave that one as is. But I do want to look at the Unix standard. Okay. Just an object, extern object, referencing a bunch of externs. Okay. Alright, so this looks like a partial change request. One 642, 1642. Yeah, okay. Okay, so that's just waiting to be merged. We'll skip that. Okay, so this is another just open pull request that needs merging. That's a pretty common pattern with Scala native. I'm not sure what to do about those. I mean, one is just to make sure that these are all rebased properly and contribute some rebases where necessary. That might be pretty useful. I think understand just got split out. Okay. Okay. Hmm. Another issue with a pull request that fixes it, all from Lee Tibbert. And I should sync with the rest of the project to see what is the status on all these pull requests. But they did mention that the bench. Aha! Here we are. Split out the benchmarks. Interesting. Oh yeah, that's exactly what I was looking for. Compile every single benchmark into its own isolated binary. The results are recorded over multiple runs, not just multiple iterations. Yes, very nice. The results for each iteration are dumped as is and summarized in a separate post-processing set. Oh yeah. That's what I'm looking for. Alrighty. Let's see what kind of benchmarks we have. Oh my. Okay. Can I just run this at all? So what I'm going to do, I'm going to say I want the entire Scala native current compiler, publish local. And it looks like that done. That was already compiled, so I'm not too worried about this. I'm going to go ahead and fork this to myself. Copy that. let's see what the build file looks like. Enable plugin, Scala native plugin. Okay. Okay, it is using 0.4.0 snapshot, so it should reference the one I want. And the README says Python scripts / run.py. What does that look like? That's interesting. Can I just ask it to compare JVM versus the current? That would be cool. I see. Okay. Yeah, that looks really cool. So let's check this out. Let's give it a shot. Python scripts run and see what happens. I'm in NixOS right now. I don't really know what my Python setup is actually. I don't really use much Python, so I wouldn't be surprised if this doesn't run into some type of Python library that I'm missing, but we'll give it a shot. Okay, while it is contemplating its existence, let us check out these. Right. What do we got? CD benchmark. Community benchmark. Number of aircrafts, number of frames, simulator num aircrafts, detector, collision detector. Okay. What does a collision detector do? A collision detector is a red-black tree mapping from call sign to vector 3D. Let me check out the red-black tree. Key is indeed call sign, and V is a vector 3, and call sign is comparable. I presume it's just a string equivalent. Right, pretty standard red-black tree. We got minus call sign. Oh, okay. Call sign was actually an integer. Oh, it's fine. What the simulator looks like. Simulate for each aircraft. We have it go basically in a circle. Yeah, sure. Is it done yet? Oh, successful. It's progressing. Cool, cool. What else we got? Some collision detection benchmark. That's pretty cool. What is this? RSC benchmark? This looks like a regex benchmark. No, not a regex benchmark. Looks like a Scala compiler of some degree. Is it actually doing anything? I'm not convinced it is doing anything. Cool. I don't see anything that is going to verify input stream or buffered input stream. Not too surprised on that. Be much value there, I suspect. But yeah, I don't see anything directly, so that's fine. Would be worth seeing if such a thing can be added. No, but it looks like something's stuck. I'm not convinced this is progressing. So I'll have to sync with them later. Figure out what the heck is bounce benchmark. Yeah, I don't think that's doing much of anything. So I will have to investigate that further. I'm actually out of time for today. Not a very exciting stream. Doing the transformation for tail recursive, which much faster than I expected. So next time, figure out something deeper to do. Maybe dig into these a bit more, or this one a bit more. But it looks like I need to sync with the rest of the group to see what would be the best path forward. Yeah. Anyways, have a good rest of your day. Until next time.